see if this works. Thank you. All right, okay. Hello, everyone. I'm very excited to be here. I'm sure there's going to be a lot of great discussions. I hope that I can contribute to them. We have a lot to discuss, so I'm just going to get started. We are, for the first time in our lives, in a position to really transform wireless connectivity from a simple data pipe to an intelligent network that will enable you to deliver these differentiated AI services. This transformation is going to consist of three verticals, or actually the intersection of these three verticals: AI, high-performance compute and networking, and wireless connectivity. So we're going to go on a journey where we're going to see that intelligent network is the fundamental building block that you need to maximize your investment in artificial intelligence. Before I do that, I'm going to start with why is NVIDIA here? What are we doing in wireless? Then go over some innovations in wireless and AI, discuss how we can monetize those innovations, and then give you some real-life use cases and draw some conclusions. I figure the best way to start is give you a brief history of NVIDIA. We were formed in 1993. GPU came out in 1999, and in 2006, our CUDA language came out. And CUDA is a programming language, an extension that allows you to develop your applications on top of GPUs. And we've been successful at that in accelerating computer graphics and user gaming experience. Around 2012, there was a researcher in a university in Canada that was having issues completing his PhD in artificial intelligence. His computer simulations were taking a very long time to run, and he needed to rewrite his math, which was inherently parallel, into serial to accommodate the platform. And I'm sure you all will agree with me that that is an obstacle that hinders innovation in artificial intelligence. He was introduced to a GPU in CUDA. His simulations were able to run faster. And one lesson that NVIDIA learned from that is when you reduce the time from a researcher's thought to results and feedback, when you reduce that cycle, innovation accelerates exponentially. Around 7 years ago, we started our journey to transform the network. We view wireless connectivity to be an integral part of artificial intelligence evolution. And we also view artificial intelligence to be an integral part of the evolution of wireless connectivity. Both of them go hand in hand. On one side, you have devices. On the other side, in the cloud, you have your machine learning, training, and inference. The devices can be viewed as sensors that take the data, send it to the centralized location. You train your models and inference and send it back. And so what we've started was to develop a platform, a converged platform that allows you to run AI applications and support its evolution, as well as wireless connectivity and support its evolution together to create an intelligent network. And that product that we have is called Aerial, which does that. We demonstrated it with 5G and are continuing with that for 6G. We are very successful in that, successful in the sense that we have great performance and capabilities, that we wanted to also rethink how networks are deployed and utilize a digital twin in supporting that simulation capability. So we're going to start by looking at making some observations on AI evolution, then connecting that with wireless connectivity evolution, and introduce the intelligent network, okay? So AI evolution, seems like I can't walk too far away from the podium, right? So I'm going to have to stay close. Okay, so what's happening in generative AI? It's exponentially increasing. What is exponentially increasing? The usage, capability, and complexity. So let me first take a look at usage, right? So here what I do is I show you a plot of applications and the time it took for them to reach 100 million users, and in terms of months. The application is TikTok. We're all familiar with that. That took about 13 months to acquire 100 million users. ChatGPT took 2 months, and everybody was surprised about this. No one was able to predict this, even OpenAI. And to be honest, even hyperscalers were totally shocked by this, and that's why there is a company getting orders for hundreds of thousands of GPUs, okay, because they were not ready for this. When I look at the applications on the right side, I see social media, some communication, entertainment, some education. But when I look at ChatGPT, I see an AI industry. I see something that addresses the medical field, addresses finance, that addresses other fields, legal, etc. So when there's a new technology that's going to be deployed, I often get asked, hey Joe, what is this killer app that we should be designing our next generation networks to? And my answer has always been the same, stop chasing that unicorn and build your network on the first order principles, right? However, I'm going to modify my answer this year to say that there's no need for you to look any further for this unicorn. This unicorn has found you, and that unicorn is the artificial intelligence industry. When you take a look at complexity and capability, I show you a few plots here, and the goal here is to show you that they're exponentially improving, increasing. We have textual-based curves that show you capabilities and models that have been released. Multimodal models, again, capabilities and tools that have been released. And there's many reasons for that, and I'll give you three. One is the BERT, the invention of the transformer. That was an efficient way for you to extract data and generate data. So that was a great accelerant, if you will. And then another reason is the availability of compute. There was nothing hindering you from running your applications, developing your mathematics. And the third reason is software defined. Now everything is software. I want to make a change to my model, I can make a change, I can recompile, and I can instantly see the change that I've made. So those three actually fueled this exponential innovation rate. We see agentic AI and physical AI experiencing the same thing. With agentic AI, now you have a model that is planning through the problem, reasoning through it, potentially using tools, evaluating its results, and then giving you back something that's more accurate. Not only we should look at it from a model perspective in isolation, an agent perspective in isolation, we do view this to be multi-agent, where these agents would be spread across a network, each serving its own purpose, and being able to communicate with each other and use different tools. Physical AI is connection of the AI to the physical world, connecting it to a camera, connecting it to a robot, to a car, to a drone. And that's going to give some new interesting use cases and also impose some really tight restrictions on the network to be able to do some processing close to where the data is being generated, right? And we'll introduce the word edge for that. So just some observations and conclusions. We're just getting started. I know that those curves show they're exponential, but they're just getting started. And AI is exponentially innovating from going from generative AI to agentic AI to physical AI. The apps are becoming more useful. There are more users on it. The models are becoming more complicated. And a very interesting part is that now you're getting charged subscription rates, which was not done before, which is great. That's an indicator that they're becoming very useful. I use it every day to help me become better, become more efficient. Some of these apps are going to require you to move from a centralized one location training and inference to a distributed training and inference. And that distributed training and inference doesn't always imply going to the edge, right? And we're going to discuss what the edge is. It's distributed. So with these multi-agents, you'll be able to put them across the network. Physical AI may not necessarily have to rely 100% of being at the edge. So, and the benefits of the edge, the benefits of distributed are lower latency, lower transport bandwidth that you have to send data back and forth to, improve the security and privacy, and also reliability. The more equipment that the packet touches, the more unreliable it becomes by the time it gets to the end source. So if an application is a mission critical option for you, which I should say where failure is not an option, then you really want to investigate your network. We still have a question we didn't answer. So where is this edge? Is this edge your laptop? Is this edge that RJ45 connector on the wall? Where is that edge? And we really believe that wireless connectivity is going to help us answer that question. So wireless connectivity is also exponentially growing. Here I show you some data rates from previous generations. 2G, 3G, 4G, 5G. 6G is not there yet. It's being discussed. These are projections of what 6G would be. But to show you that there's an exponential trend happening as well. For some demands of 6G relative to this conversation, mobile data traffic is going to increase by at least 5 times by 2030. And that's, depending on which report you read, that can be much, much more. And of that traffic, AI is going to be about 30%. So that means about 1/3 of the traffic is going to be generated from AI apps and the data that it generates. So we really need to be considerate of that now, today, for us to be able to handle that in the future. Complexity and capability is also growing, right? The next generation standards are figuring out different ways to deploy networks. They're looking at non-terrestrial networks, including satellites, putting base stations on drones, on blimps, integrating sensing, where the waveform that you transmit in this room now becomes a radar, and it bounces off people and objects, and now it can reconstruct buildings, it can reconstruct people and objects. And then reconfigurable intelligent surfaces, where you place a surface on the side of your building or indoors, and basically what happens is any signals that arrive at that surface at a certain angle of arrival gets amplified and then transmitted with a certain angle of departure. So users that were at the edge of the cell that potentially had 1 bar now have 2 or 3 bars. So there's tremendous benefits in that. And another technology that's really gaining interest is digital twins. And that at the bottom I show you an end-to-end physical world, and above it is a one-to-one digital twin that I put in a rectangular box. And the whole purpose is to extract data that happens every minute, learn from that data, train your models, and then look at all the different options that are available to you. You pick the best option, and then you take that configuration and directions, and you push that proxy to the real world. And then you monitor the results of that. Did that event happen as I planned it? What could I have done better? So that cycle is always present, and we're trying to reduce the time in that cycle so you can accelerate innovation. So not everything is great, okay? So here I'm showing you a plot of wireless data evolution, and that's the black line. And that's evolving exponentially. We can't dispute that. And what we see is that about every 10 years, we get a significant jump in wireless connectivity. So the units of time are 10 years, decades. And I plotted the curves that I showed you before, where we talked about textual-based, multimodal, and agentic AI. I plotted them on here as well. I overlapped them. And you can see that the units of time are in years. We measure units of time in years. And so what you see here is that AI is exponentially innovating 10 times faster than wireless connectivity. And to me, that's something to worry about. Why? Because you see that where AI is evolving at a rate much faster than where we plan to be in the future with 6G. It's not that I can say, don't worry about it now. In the future, 6G is going to innovate faster. It's not. So we're behind the curve, and we're going to stay behind the curve unless we act today. The applications have been data center, we discussed, centralized, your training and your inference. And with 6G and evolution, you'll see more on-device AI. And now you need to be able to coordinate between the on-device AI and what's located deep inside your network. And, you know, no pun intended, but the network is uniquely positioned in between them to take this opportunity and become intelligent and allow you to deliver these differentiated AI services. But we must embrace the change today. The longer you wait, the more difficult it is for you to make a corrective measure, because these curves are getting further and further apart. So using your classical way of thinking is not the right way to go forward. So some observations here. Yes, wireless connectivity is exponentially innovating. We want wireless connectivity to innovate faster. So what's a good way to start? Well, let's start with the lessons that we learned from AI, right? You know, having compute available, having software driven, and also having open source. Last year, about 70% of startups used open source models to help develop their applications. And for that open source models, you needed to have compute and software to be able to run that. So that's a very important part to be able to look at. So where we're going to a native, AI native solution. An AI native in this presentation is an AI model that is responsible for making a decision, and the output of that decision is going to be evaluated so it can be improved in the future. It's not a ML model that makes a prediction and stops and waits for you. This is a continuous event that's continually monitoring and improving and becoming more and more useful. We discussed with this intelligent network having the ability to deploy the workloads from a centralized perspective all the way down to your edge and in between. And we talked about enabling, these will enable new use cases. So basically, wireless connectivity found AI home. AI now has an edge, okay? So we have this innovation. What are we going to do to monetize it? So the best way is to show you this very simple diagram. On the top, you have your data center, which has your apps and your data, where you're training and you're using inference. And you're going to need to connect into the wireless connectivity network. And the first thing you encounter is something called a core network. The core network keeps your subscriber information, assigns quality of service, the packets that come in, et cetera. And then you go into your access network, and the access network is responsible for this is what my demands are from users, and what do I have available, and I need to meet and match those demands as much as possible. We have a symbol of a radio there, and then you have all these devices there. And I purposely picked these devices because they're very different from each other. The devices are very widely varying, and they're also very wildly varying. Some of them want high downlink data, some of them want like high uplink data, some of them can tolerate latency, some of them cannot tolerate latency. Some of them are mission critical where failure is not an option. Okay, if I have to make a left turn, I need to know I need to make a left turn. Don't tell me later, right? So we can start here, and then you say, okay, thank you, Joe. I see that AI is evolving, so I'm just going to sidecar AI. And so now I have my equipment sitting on the side there, going through a security privacy wall to protect the network from anybody who has any malicious intent. And I now have a AI application domain, and I now have a communication domain, right? And you can go ahead and think about that. But really, the edge there is not the edge close to the users, it's more at the interface. And the reason that is because we saw the AI apps, AI is innovating much faster, and its platforms are innovating much faster than wireless connectivity. So by definition, those wireless connectivity capabilities will be delayed in time, and you will not be able to utilize them, for example, to build your digital twin or support interfacing to agents inside the network that has useful information for you to develop your applications. There's a lot of tension here, and with the tension, you're going to get stress. And with this stress, you're going to lead to all of these negative parts about underutilized resources. In connectivity domain, I really can't run a lot of AI apps, so I really need to go to my AI app domain. And in my AI app domain, I really can't do any wireless connectivity because I'm tied into those hardware accelerators, so I have to run them on the other side. So you have two domains that are running independent of each other, and you're going to have moments where the devices are not connected or idle, that you're wasting resources. The total cost of ownership here is very high. The inventory is a nightmare to manage all of these different solutions that are available. And when you want to go out to deploy, install, debug, and test, there's two languages you have to talk about. On the left, we talk about beamforming, MIMO, signal-to-noise ratio, modulation. And on the right, we talk about tokens, transformers, Python, a neural network. So the languages are very different, and there is an attempt to converge them as we get further and further, but they are very different. This approach is not very scalable, and I think the key takeaway here is to deploy a model on legacy equipment is not going to work. It's just not going to work. And I understand that's a big statement, but we've done this before. We've done this more than 10 years ago, and we did that under the heading of MEC, Multi-Access Edge Compute, where we tried to put applications at the end, and we were not very successful at it. And if you forced me to say, hey, Joe, why were we not successful, and give me one sentence, I would say we were not ready. And I'll give you some examples on the left side why. But we were not ready. We've done this before. And so this is the time where we have to rethink how we're going to deploy AI applications and also new wireless connectivity technologies together. On the top, edge benefits. We knew that back then. It's not like we didn't know. And we know them now. But there was nothing pulling it, right? And you know where I'm going to go with this. I'm going to introduce you to that unicorn again, who now has AI applications and AI and wireless connectivity. So you're going to be driven by AI. It was very costly to implement, to deploy these solutions, even if you purchased the equipment for operators, which is very expensive even to maintain. And so what we're doing is we're going to this converged infrastructure where you treat the wireless connectivity as an application. It could be a container if you're interested in that. And the application is a container, and you can deploy them as if they are any other workload on a converged infrastructure. Not everything you can is going to be helped with AI. Okay, something has to happen with the network itself. Today, the majority of networks that are deployed are what's called non-standalone. So if I want to deploy 5G in your system, in your location, I have to bring 4G. And there are 5G standalone deployments, but not many. If I look at them across the world, they're very little percentage. The majority of them are non-standalone. But we are about 6 years, 7 years into deployment, and we're not fully utilizing the benefits that 5G was designed for. And so 6G is thinking about that ahead of time to making it easier to, when 6G is introduced, I can go directly to a standalone and I can benefit from this. And this is something that AI will not help you with. And we talked about hardware design moving to software defined. So what is the solution when you put this wireless connectivity and AI applications together? You have a platform that you can run both of them on, right? And so now you can benefit. Wireless connectivity has room to innovate faster because it's running on a platform that AI is running on. And we already know that AI is innovating at a faster rate than wireless connectivity. And then because they're both running at the same time, what that really does for you is it simplifies the way you deploy these services. You have a unified orchestrator that I can load a wireless connectivity at the same time as artificial intelligence applications. And so everything that we said earlier that was negative now becomes a positive. And the last thing I want to say is that, the edge, where's the edge now? The edge is truly at the radio section. That's because you enabled the wireless connectivity to evolve faster, and you can put agentic AIs into the network. You can utilize digital twins in the network, and so now the edge has moved closer to the devices. Here we see everything that we discussed in the past about being negatives have become positive, and importantly, it's scalable, where now the more equipment that you add, you can immediately see an impact from, because they can be reused not only for wireless connectivity but also for AI applications. And the last one is this path to revenue generation. So I want to review something. So at the beginning we said this intelligent network is the fundamental building block for you to maximize your investment in AI. And so that consists of running AI and AI applications and wireless connectivity at the same time in the same network. Being software defined is important. Having the ability to support open source, being scalable, and the last one is being able to do centralized and distributed. The combination of all these in an intelligent network opens up a lot of new use cases and provides opportunities for monetization. On the right, we talk about what specifically it's for you to move away from a fixed traffic model to a model that delivers differentiated services, AI services. And you'll do that with what avenue? And you can do that to AI as a service, compute as a service, platform as a service, and local hosting. A while ago, I showed you deploying a machine learning model on a legacy network is not the best thing for you. So you can take that philosophy as little or as much as you want, and you can deploy it and use that for software. So if I have a software function and I'm going to replace some of it with an ML model that is an AI-based model, for sure, but that's not the AI as a service that we're discussing here. We see there's another layer that's coming where you can utilize open source tools that already exist, like ChatGPT, Gemini, Claude, and use that to develop your applications on top. We've been very fortunate to work with a whole bunch of partners that just released the Earth 2 model. It's a world model that simulates climate and predicts weather patterns. You can develop an application that interfaces to that. So this AI as a service is building on top of those open source models that exist. Those open source models have roadmaps. They're evolving exponentially, and it would be great for us to take advantage of that. So I want to go over some monetization use cases. So the first one is going to talk about the interaction of the digital twin with an immersive experience. And if you look at the top right picture there, it's a pretty popular home improvement store that's creating a digital twin of its physical store. And it does that to look at inventory. They have a digital twin to look at traffic flow. Where should I place these, this equipment, these products? The immersive part with cloud augmented reality is to improve customer training, your employees. And you see you can start with this and you can grow. If you have a particular section of your campus that needs to be reinvigorated, you can create a digital twin of it, look at traffic flow and see what's the best way, what's the best tenant to add into your property. The next two is the connection to the physical world and the data collection. One thing that I hear said, and I don't agree with it, is we're running out of data, and we're really not. This morning we have more data than yesterday, and this afternoon we're going to have more data than this morning. And so being able to use that is very important, and physical AI is a good way for us to close that loop. Here's an example where there's an agent that's connected to a camera, and you basically ask the camera, you know, what's the conditions of the road? The camera has to figure out, I don't see a road, I see water, you know, and oh, by the way, it is raining. And thank you for giving me a ruler, I can figure out it's almost 2 feet. And that agent can then, based on the tools that you give it, can go ahead and start to look for, search the internet for any announcements on storms that are coming. It can interface the weather data. It can then interface to your emergency services and figure out what's the best way to take care of this, predict where you should be going. So this is just the beginning of that. Here's an example that we have done with T-Mobile. We have 3 sections here. On the left, we have our users. The middle, we have the edge AI, the intelligent converged infrastructure. And on the right, we have a private cloud. We're able here to show that you have wireless connectivity and AI applications running on the same server at the same time. So you've been able to take wireless connectivity, treat it as an app, and deploy it together with your AI applications on a platform that enables you to accelerate innovation exponentially. And there's 4 users here, and 2 are coming into the wireless side, 2 are coming into the wired side. These can be your team, this can be looking at proprietary data, this can be discussing projects with your customer. In this particular case, the model is a Llama 70 billion parameter that was trained using retrieval augmented generation. Why was that done? Because we brought in proprietary information from T-Mobile that should be answered only within its space. Okay, so it's open model that was trained and customized for T-Mobile's proprietary information. Let's say a user wants to know more information about something. This person opens up a chatbot. That chatbot has an IP address that's pointing to the application that's inside your intelligent network. And there it can start to access information and start exchange information, the proprietary and secret information to your company. Because we have an intelligent network, you can connect these. And so we can expand this scenario to include a private human digital avatar. So I speak, it's converted to text, the text goes to the model responds with an output, the model goes to, a bit gets interpreted, and the human avatar figures out the facial expressions that it has to respond to. And it has to make sure that if something sad is happening, that it doesn't smile. and laugh, right? So it has to be able to interpret that properly. And here we say we have them in 2 different locations. Last one is from SoftBank, and we have been in discussions with, I think, about at least 65 operators worldwide, trying to help push technology through and enable them to develop products. Here's an example from SoftBank where I show you utilization as a function of a 24-hour time period. And there's going to be times in the day where you don't really need a lot of connectivity. And so I have a rack of equipment, and I want to use the underutilized resources for AI. I want to use any of those avenues that you said, Joe, AI as a service, compute as a service, platform, local hosting. And the answer is you can. So in this particular case, it could be an area where it's a holiday or a weekend, and a few of the resources in the servers are in the rack are used for 5G, and the rest can be used for AI. And then later on, what happens is, you might have a concert, you might have peak time. This is a very popular scenario in Japan. And so now you're going to need a lot of 5G resources to accommodate all these users. And so now you can relocate AI apps to another part of your intelligent network. This paper was created with SoftBank about 2024. It's a little bit more than a year old, but it'd be great for you to look at and update according to your proposals. They developed a system that does 25,000 tokens per second, which is not really a lot and it's not a little. And based on that, they've defined a potential revenue of $20 an hour, which comes out to be about $15,000 per month per server. And if you will allow me to make my math very easy, okay? Let's assume you have 10 servers, so that's $150K per month in that location. And say you have 10 IT rooms, that's $1.5 million per month on that. So that's just an example when generating tokens. There are other use cases that generate more and other use cases that generate less. So just to conclude, we know that wireless connectivity is evolving. AI innovation is evolving faster. We want to enable wireless connectivity to evolve faster. How do we do that? We create this converged infrastructure where you can run AI and wireless connectivity on the same equipment. By doing that, you now have given AI an edge. And by doing that, by this intelligent network, you can have centralized, edge, and distributed applications spread across, which is what we believe is important for your network to support in the future, to support physical AI and multi-agent AIs, to create your team based of AI agents, okay? And that will provide more monetization opportunities than the ones we discussed. And then the last thing is to say, the unicorn has found us. And these actions, we really should take action today. And please don't get left behind. Thank you very much.
Great. Nick, thank you. So, Joe, thank you for that. That was terrific. Let's ask a question I think everybody wants to know. We're going to do some questions from the field, too. These people are mostly vendors. There are a lot of AHJs and other types here, but they're vendors. So they're going to a customer, and the customer's saying, I'm not paying for in-building wireless. I'm not paying for any of this connectivity. All of this goes nowhere unless they agree to do that. So if, in your opinion, what do they say to that real estate owner or that hospital or whatever that says, I don't want to spend money on this? They'll get left behind. How do they convince them that this is what's happening and they'll get left behind unless they do this?
That's a good question. I think that you would have to have some narrowed down version of this presentation is what I would say.
Yeah.
To say that, AI is innovating much faster and you won't be able to utilize those AI services that are good for medical industry to help you doctors become better unless you deploy this, right? And of course, there's service providers are slow in moving, okay? Let's just say it that way. They're conservative, okay? So they're conservative moving, so you're gonna need to do some new techniques to accelerate that.
Right. So all of this, you brought up a sore point here, T-Mobile, because all these folks are talking to T-Mobile on a regular basis. T-Mobile's saying, I'm not paying for it either. So, leave me alone. You want to buy a radio, buy a radio. But other than that, so where do they need to go to get to connected to you, to NVIDIA, to this kind of technology so that they can be more effective in what they're doing? How do they do that?
That's a good question. I think that the work that I do is about 5 years ahead of time. And so I'm already engaged with their research groups. They've committed and they're converting that down. So today you're not going to find this. And there's only a few people that are pulling it, like SoftBank. T-Mobile is interested, but they don't have plans yet to commercialize it, but SoftBank does. So it would be able to not speak to the people that you're speaking to now. Let me say that, because they have blinders on in a good way, not a bad way. The technology that they have currently is the best, and that's true. But they're not seeing what's coming in the future, or they may not be seeing what's coming in the future. So don't keep speaking to the people that you're speaking to now. Go around them, go above them, go under them, okay? Any way you can to get this message through, because if you don't make the change today, you won't see it in 5 years from today.
So we are videotaping this entire presentation, and will be available.
I'm only kidding.
So is this presentation available to these people?
Yes, we can. We can make it.
Good.
Yeah. You have
Okay.
a website, we can put it in your
Beautiful.
website.
That would be terrific. We can put that up. Are there questions from the field that anybody would like to ask Joe before we break for lunch? There's got to be somebody here.
Yes, sir.
Yes, sir.
To ask how important the multi-tenancy aspect of it, as it pertains to the neoclouds that are all being built, and how that kind of impacts the whole edge space and data space.
I think it's a very important aspect of it so that you can deploy wireless in the same place, in the same way as you do other applications. So it is an important part, because in the past we've always said, hey, wireless is the special child. I have to treat it differently, right? That comes with its own baggage. But that's no longer the case. I think it's incredibly important to be able to merge them together.
What, if you knew we were videotaping, you would have worn a tie, or what was the difference?
I would have wore a tie.
Any other questions? Yes, sir.
Joe, great presentation, thank you. Talking to property owners,
Property owners, okay?
what are we looking at in terms of radios that I need to put into a building?
Right.
Ultimately, what am I getting back for it? And talk to me about, in terms of security, cybersecurity, big issue from a property owner.
Right.
Don't want to touch telecommunications, because if that goes down, now you're going to stop paying me rent. Can you talk about those issues and how you dissect that when you're speaking to property owners?
Okay, that's a good question. So I think that radios then we need to talk about spectrum, okay? And that's a key thing, if it's licensed, unlicensed, or shared spectrum. And to me, I purposely didn't use words like private 5G or enterprise, because I believe what was mentioned here is pretty much true for everyone, whether it's private or public, if you will. So I think on security, because we're going to distribute it, centralized has really done they have a lot of good security principles, okay? A lot of stuff that was learned there. We're reusing that and building on it. So I think from a security perspective, it's in good shape, honestly, because we're building on principles that have been deployed, centralized in that. In terms of equipment, I hope now that you see a different way to deploy this. And if you go to convince a property manager the benefits, it's not only the wireless connectivity side, it's the fact that I can merge that and use the wireless connectivity to benefit from the AI side. I'm not sure I answered your question, but.
Good enough.
Okay.
So two things real quick. One is, many of us are friendly and of course know of Vertical Bridge and Digital Bridge, the parent company, which was just acquired or in the process of being acquired for $4.4 billion by SoftBank. And Joe and I had a conversation about this. Seems like that enlightened company is coming here, and if there's one place you might want to be talking and looking at for help in developing the future for you, it might be SoftBank coming here through Digital Bridge, which is data centers and yada, 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 and all those things combined. Also, I want to thank Googly, Dan Leaf, for being sponsor of Joe's presentation. We will be providing that on our website, and we will be providing the video. We'll be cutting it up and using it on social media and stuff, so excuse Joe for not having a tie. But at the end of the day, any other questions that you'd like to ask before we let Joe go and we do lunch? Yes, sir.
Joe, is kind of follow up to that question.
Sure.
You're creating the GPUs and creating this performance at the real estate site. Is there a revenue stream for that to create like part of a virtual, creating a virtual data center, so to speak? So you're leasing out the GPUs in the rack space, right?
Absolutely, absolutely. I don't know.
I think you pointed that out.
Yeah. Those avenues that we briefly discussed, like AI as a service, platform, compute, local hosting, that's a significant part that we would see there. That you now either can use that compute capability to deliver those differentiated services to your tenants, or other buildings can come in and reuse that. So yeah, that's a significant part. I think it's even more so now because you know that these AI factories that are being built have a power issue, right? And so it's a great opportunity to do a distributed data center.
Yep.
Yes.
Last question, and we're going to stay on schedule here for lunch. Any other questions? Oh, yes, in the back.
How do you think about the fact that if you're merging brands of AI, some of the models that you're putting in, like Llama, for instance, Keynote, already multiple versions have it too. How do you think about updating that in the context of a network that is supposed to be deterministic and very future-proof?
So the Llama models that we had was an AI application that's running next to, it's separate, yeah. And because you can deploy wireless connectivity and AI applications, you can change, you can lifecycle manage them separately, yeah.
So it's lunchtime. Please avail yourself of food in the back. Thank you all for listening, and that was terrific. Thank you
Thank you
so
very
much.
much.
Thank you. We're going to break for lunch now and enjoy, and then we'll be back in a little bit close to an hour.